Excellent. So today we're going to talk about auto, what it means, and how it comes to be. And it's going to be a bit of an adventure. When they asked me to give a talk here, I was like, what do you want me to talk about? They said advanced stuff. And I was like, okay, we're going to look at how does the layout engine work, because that's kind of advanced. So my name is Elika Etamad. I'm better known as Fantasai. I've been in the CSS Working Group for over 10 years. I started at Mozilla in 1999. I'm one of the old people. I've worked on a lot of the specs. If you have problems with our specs, probably I am somebody you can complain to. I don't take responsibility for anything prior to 2004. So we're going to begin, and we're going to just dive right in. So how does the layout engine work? There's 4 phases to doing layout, more or less. The first one is style computation. This is where we take all of the elements in the DOM and assign a value for every CSS property that exists, or at least every CSS property that that layout engine knows about. And then in step 2, we construct the box tree, so that each element is represented by 0 or more boxes. In step 3, we actually do the layout, which is where we calculate the box's sizes and positions. And then in step 4, we draw the things on the screen. I don't know anything about step 4, so we're not going to talk about step 4. However, we can talk about some of the other stuff. Style computation is per element. It's generally done with a depth-first traversal of all of the dirty elements. A dirty element, when you start loading the page, is all of the elements because they have not yet been rendered on the screen. When you do DOM manipulations, then the dirty elements are the things that you have just manipulated, and we try to optimize away all of the other calculations that we have just performed in the last reflow path. So this is kind of the opposite from the way that stuff works when you're doing a query selector, and that's where some people get confused about performance characteristics. The first step of style computation is selector matching. This is where we take, here I have an element. I want to find for this element all of the style rules that match this element. That's all of the style rules from the UI style sheet, the author style sheet, the user style sheet, everything that's linked, whatever. Just give me all of the style rules that match that node. And once we have a list, then we do the cascade, because that's where we find, of all of these things, which are the property declarations that win. Sometimes you only have one, and that's the clear winner. Sometimes you have multiple declarations for the same property that apply to that element. And then in that case, you use specificity and weight and all this kind of stuff to figure out which one wins. This third phase is that we compute the values, which means we absolutize all of the lengths, and perform various other manipulations that we can do without doing layout. So for example, if you have a length, a width in M units, we will multiply that by the font size and figure out, okay, how many pixels is that really? One area where people get tripped up by this a little bit is the line height property. If you set the line height as 1M and then you make the font size bigger, you will have lines that bleed into each other because we've converted that to pixels already. So if you're using line height, you want to put it in something that doesn't compute to an absolute length and will inherit as its own, number, factor, whatever. And that, for line height, that's an integer. And then after we do the computation, we do inheritance. The point of inheritance is to fill in missing values, so things that did not get specifically assigned to the element. And there's 2 options. 1, we inherit from our parent, or 2, we take the initial value. That depends on the property. Color inherits, text decoration does not. So then, at the end of all of this, we have exactly 1 value per property per element. And then that tells us all of the data we need to know for, like, what is this thing going to look like, but we haven't done the layout computations. In order to do the layout computations, we need a box tree because the layout is telling us what the boxes look like. For every DOM element in the tree, there will be 0, 1, or 2 CSS boxes. That depends on the display property. If the display property is none, or the contents value, which is coming up in level 3, there will be no boxes generated for the element. If most values will generate 1 box for the element. Flexed, block, inline, the element will have a box. For tables and for list items, you will generate 2 boxes. There's the principal box, which is the main box that contains all the content, and then some other box. For list items, the principal box is the block box that contains all of the list contents, and then the secondary box that it generates is the marker box. And then for tables, there's an outer box, which contains the table that you usually see. You got the table that you put borders on, that's 1 box. The outer box, the table wrapper box, contains that box and the caption. So there's 2 boxes generated for tables. This is not including all of the anonymous box generation that happens if you, for example, put a table cell in the middle of your page. We create a bunch of anonymous boxes so that it's not alone and it has a table to wrap it and keep it safe. The box so I work on Gecko, or I worked on Gecko, and so I don't know the internal details of all of the other layout engines, but most of them work more or less kind of similarly, and we're going to be at a high enough level that we'll be glossing over most of the differences. In Gecko, NSCSS frame constructor is what constructs the boxes. Frames in Gecko parlance are the equivalent of a CSS box. So, end result, 0 or more boxes per element. And so then we have two trees that look kind of similar, but they're not exactly the same, and they correspond. As an aside, a CSS box can correspond to 1 or more box fragments. So when you line break, when you page break, when you break across columns, that box breaks into multiple pieces, and each of these pieces is called a fragment. And so you will have at least 1 fragment, but you might have more if you're breaking. But we're not going to talk about fragmentation. This actually doesn't happen during box construction. It happens during layout because it depends on layout, and it's not about the relationship of the boxes as it is about the relationship of stuff in the boxes. But just so you know, that's what a fragment is if it comes up when you're reading a spec. So, okay, so we have our box tree, and the box tree consists of a bunch of nodes. What do they look like? In Gecko, that's an NSI frame, and there's a bunch of critical pieces to a box node in the node box tree. First of all, we have to make the tree. So we have a pointer to the parent, the next sibling, the previous sibling, and the list of the children. We also have a pointer to the DOM, so that we can get the content and the text. We need to lay out the text. We need to know what it is. We also have a link to all of that style data that we just computed, so that when we are doing our layout, we can look that up. And then we have what is effectively the output of layout, which is the size and the position of the box. Boxes are all rectangles, so we have a width, a height, an X and a Y position. The goal of the layout is to fill out the mrect structure, basically, and the origin coordinates are relative to the parent as opposed to like the entire document, so that when you move an element, all of the stuff in it just moves and you don't have to do any extra computation on it. Okay. This is nsblockframe.cpp. This is where block layout happens. It's order of 10,000 lines of code. So point being, we are simplifying things a lot when we look at something that is roughly this. This is a reflow method. The goal of the reflow, this is kind of what you do when you try to find it. You do a recursive call through the tree and say, hey, I need to size and position all the boxes, and you know what your children are, so like let's do this all like recursively through the tree. And the first thing that a box will do when it's been told to reflow is, well, let's calculate what my width is going to be, because as we all know, the rest of the layout kind of depends on what that width is. So we find out what the width is. And then we go through all of the children and try and lay out the children and tell them what the width is. So we're like, hey, I'm this wide. What size do you want to be? And the child would be like, well, it calls its own reflow methods and does its own children. or whatever it needs to do, and it says, I want to be this big. And then I, as the parent, say, okay, that sounds good, I'm going to put you over here. And then we'll advance to the next child and presumably increment our position in some fashion. If you're doing inline layout, you'll go across, and if you're doing block layout, you'll go down, and then you move on to the next child and do it over again. And then when you're done, you're like, okay, this should be height, sorry. And then you will calculate your height, and then now we have a width and we have a height, and we can tell our parent what it is, and it can position us. So that's the reflow method. There we go. For calculating the width, very basic ideas. If it's auto, we will find out our parent's width and subtract out our border, margin, and padding. And if it's a fixed size, we'll just assign that in. And so that's like super basic inflow block layout, CSS1, whatever. And then for the height, we will, for auto height, we're like, well, give me the position that my next child would go in, or the bottom of my last child that I positioned. Or if I'm a fixed size, make me that fixed size, and that calculates the height. So that's roughly how reflow works for, a very simplified version of layout. And that'll let you do something very similar to, laying out this page here, which is the CSS1 spec. The really cool thing about CSS layout and web layout in general is that it is super responsive, right? We can change the width of our window, and it shrinks, and nothing overflows, and it all wraps, and it gets taller and doesn't, overflow the page. And this is all super useful and cool, and we would like to keep some of these attributes as we're going forward to two-dimensional layouts. So auto layout for a basic block layout is the width fills the containing block, and then the height fits the laid out content. And then this adapts to the varying screen widths and the heights and all the aspect ratios of screens you can possibly have. And it adapts to, if you change the font size, it's fine. If you change the font face, it's fine. If you change the amount of content, it's fine. It just works. And that's the beauty of auto sizing in CSS1. It works great until we start to put things side by side. So automatic sizing in traditional print media. Traditional print media has lots of things side by side, and they do all kinds of sophisticated layouts, and they use this amazingly sophisticated process for figuring out how to fit the content into the boxes, or the boxes to the content, or however it is. You'll have a layout editor, and they'll say, hey, how long do you think your article on bicycle theft will be? And the journalist says, oh, I think it's about 500 words. And the layout editor will say, well, okay, I will make you a box on page 3. And the journalist is like, okay, I will write my content so that it perfectly fills the box. This is actually how it works in a lot of newspaper companies. Automatically sized to fit, everything fits, right? But it requires a little bit of jiggling around, and it doesn't work on multiple screen sizes. So, which is fine when you're printing, it doesn't work for the web. And that's why we have to do things that are a little bit more complicated on the web. So CSS, we have some principles of design. One of them is that we don't have the principle of like it's going to look exactly the way I thought it was going to look, but we have some other principles, which is we want to create a layout system that's flexible. We want it to adapt to different screen sizes, different environments, to different amounts of content, and it should, handle that continuously and not require you to give a different layout for every different pixel size of screen that you come across, or every time somebody, fixes a typo. We want it to be powerful, so we want it to be able to express all of the layouts that you all authors want to show on the screen, and we want it to be able to do that, in a robust way, so that if something changes that you didn't expect, like it displays on my computer, which is not very big, you see, it is still readable and it still looks good and it doesn't look like anything's broken. We want it to be understandable. So we want authors to be able to use it and understand it and be able to, be comfortable with it as a tool and not find it to be like this horrible thing like float layouts that really are painful to work with. and difficult to learn. And we want it to be performant because the web platform is used for interactive layouts. And so as things change, we want them to change and not hang your computer, because that's not fun. So this brings us to the topic of we come back to auto. What is auto? Sylvan has this great quote, which is, in CSS spec editing, you should expect 80% of your time to be spent defining what auto does and does not do, and then you're fine. This is not really that much of an exaggeration. The CSS Working Group really does spend a lot of time figuring out what auto means and how it works. And so we're going to dig into some of the details of what that means for layout in the next section. Am I losing anybody so far? Please raise your hand if I'm going too fast. Okay. All right, so in terms of defining auto is a magic thing that involves lots of calculations. So first we have to understand, what are we building it out of? There's different types of sizing primitives in CSS. We have fixed sizes. These are sizes which are independent of the layout and independent of the contents. You say, I want this to be that box to be that size, and it will be that size for some definition of that size. There's extrinsic sizes, which are sizes that depend on the containing block size. We saw that in the CSS1 layout, where the size of the paragraph depends on the size of the div that contains it, which depends on the size of the viewport. And you just subtract it out. There's no dependency on the contents. There's no dependency on, like, the author gave, like, some number that we have to hit. There's no target other than we want to, like, fill our containing block to some percentage. The other type of sizing we have is an intrinsic size, which is a size that depends on the content, and that does not depend on things outside of it. So, fixed sizes. There's two kinds of fixed sizes. There's absolute units, which is pixels, points, picas, inches, centimeters, millimeters. These we're all familiar with, particularly everybody uses pixels around here all the time. They don't really respond to anything that's happening in your layout or in the environment of your page. They're just kind of there. Then there's the relative units. We have font relative units. These are relative to measurements of the font being used. We have M, CH, and rem. M is the height of the font. CH is the pitch, average pitch of the font. And the rem unit uses the font height of the root. So it's a lot easier to use because you don't, as you change font sizes, you have like some one reference. You don't have to do math depending on how deep you calculate. Then we have the viewport units, which are relative to the size of the viewport. So you can express your layouts in terms relative to the font size and relative to the viewport, as well as in absolute units. But these are all fixed sizes. They're established when you start layout. You don't have to do layout to do it. You don't have to measure any content. It's just a result of style computation. The next thing we have is the extrinsic sizing. We call it fill available sizing in some of the specs. It's just how blocks lay out. As you know, just subtract out the border padding in the margins and get from the containing block size, and then percentage sizing is the same thing. You're taking a percentage of your containing block and you're referencing that containing block. Then we have intrinsic sizes. There's two different kinds of intrinsic sizes that are used commonly in CSS. For images, they're both identical, but for text content and other like laid out content, we have a min content size and we have a max content size. The goal of the min content size is roughly what is the smallest I can get before I start to overflow. So the largest image, the largest fixed size box that is a child of mine, or the largest unbreakable word. If you shrink down a table, at some point it stops shrinking. That's the min content size of that table. Then there's the max content size, which is, the goal is roughly the largest size that avoids wasting space. So that'll be the largest image fixed size box or an unwrapped line of text. So if you increase the width of your screen on a table, at some point the table stops growing with your screen. That's the max content size. Then we have compound sizes. The compound size is the size that combines some of these other things in some sort of a formula. The most common one is the shrink to fit formula, which is used for tables, which is used for floats, which is used for absolute position. The goal of this is to fit around the content, but also to, at the same time, avoid overflow. And then we have another type of compound sizing, which you learned about earlier today, which is flex. The goal of that is to be able to put stuff next to each other and then distribute the extra space. All right. So shrink to fit sizing is actually a min-max formula like this. It says, be as wide as the content, but don't be wider than the content. But try to avoid overflowing the containing block. So take the smallest of whichever those two are. But definitely don't let any content overflow the box. So be at least as big as the min content size. And that's the shrink to fit formula. For flex, you start with the basis and then you multiply the flex by however much free space you have, and then that gets, so that's a combination of either fixed sizing or intrinsic sizing and some amount of extrinsic sizing. And then to make things even more complicated, we have some sizing constraints. You can specify a min or a max width or a height, and then the goal is we'll size within that range, don't go outside it. And then we have aspect ratios on images, and the goal there is don't skew my image. So automatic sizing needs to account for all of these things. So defining auto, well, what is auto? It depends on the layout mode. For block layout, it's extrinsic fill available. For floats and tables and abspos, it's the shrink to fit formula. For most heights, it's just the content-based height after you do layout. And for an image, it's going to be a function of the image's intrinsic size, any specified sizes you gave it, any min and max and widths and heights that you might have given it, and the aspect ratio. And then for flex items, it's going to be your flex places plus the amount of free space that you've been assigned, and then you're going to be at least as big as the minimum size, which for flex items is implied. Flex items have an implied minimum height, which tries to keep things from overflowing. So why is it auto? Like, what do we do to try and make something auto, and why do we come up with this as being the auto thing? One of the goals of an auto value is it gives reasonable results. We want to avoid data loss and overflow, so auto is trying to do something that avoids those things, that avoids clipping. We want a value that is good default for building on, so that people want to do different things with a layout module. They will be able to start with auto and then modify things from there and have that make sense. And auto is something that does auto magic. So somehow magical. If it wasn't magical, it would be some other keyword, and it might have all of these other benefits, but we wouldn't call it auto. So for Flexbox, FlexBasis Auto does some automatic things. Well, one, it looks up the width or the height, whichever is the main size property. If that is auto, then it uses the content-based height. And it doesn't just, at first when we wrote the Flexbox spec, we had it just be the max content size. But then we ran into issues, well, for images that didn't work very well. So we started to incorporate, well, we have to take into account the aspect ratio. If somebody set the height and then now we have an auto width, we should account for the height in the auto width and not use the intrinsic size of the image if it should compute off of the aspect ratio. So auto became a little bit more magical than just the max content size. But it's still kind of like based on the content size. The initial value for the flex grow property is not auto because we had another value that we could call it. We could call it 0, so it's not magical enough to be called auto. But we chose that the initial value for flex grow is not 1, it doesn't grow. And the reason we chose that was, even though it's called Flexbox and it doesn't automatically flex, it means that a lot of things you can do with Flexbox are one step away. You want it to flex, you can set the flex value to auto or to 1. If you want to use the alignment properties, they're right there. The alignment properties won't work if you've flexed already because you already ate all the free space. There's no more to give to the alignment properties. So we chose to make things not grow by default. But we did choose to make them shrink by default. And this was going off of the idea that, like, well, we should try to avoid overflow. In a lot of cases, authors will put a bunch of stuff together and not think about the fact that not everybody has a monitor this wide. So if you have some text and you have some images and you stuff them in a flex box, by default, those flex items will shrink, unless you say, I don't want them to shrink. But if you keep shrinking down to 0, that's no fun either. So we have an implied minimum width, which is min width auto, and it uses the min content size. As we saw, that's the size that if you keep shrinking it, it prevents it from overflowing. And so that's implied on minimum on flex items. There is one disadvantage to this. It's a little bit more computationally intensive because you have to go dig into, if you set it like on your body or on like your main article, then you have to dig in and find the min content size, which involves looking at all of the content inside. But for a lot of the things that flex is used for, which is like smaller things like tabs across the top or various, widgets and stuff, doing that computation is very quick and fast. There's not a lot of depth, there's not a lot of content to analyze, and it will get you better results in general. That's about auto. And how am I doing on time? 20 minutes. Okay. As usual, I'm a little bit fast when I get on stage. So I'm going to take this opportunity to go over some CSS best practices. They're different from the ones you're going to hear about next. Those are about style selection and things like that. This is about layout. As we heard before, with great power comes great responsibility. Please, when you are reordering your visuals, reorder the source, not by using order or positioning or a grid layout or reverse flex, unless there's a reason that you want to keep the visual order and the logical order out of sync. So linearized logical source order. That's like, if you were going to read the page, what order would you read it in? That's the order that should probably be in the DOM. Liquid layouts and relativity. So we put all of this effort into making CSS fluid and to giving you lots of units to play with. We need you to think about that and use them. So when you're sizing things, instead of just reaching out for pixels all the time, think about what is your sizing based on? Why am I making this box this big? Am I trying to fill the containing block? In that case, I might want to use percents or an appropriate auto value. Maybe I'm based on the viewport size, like the text here that I have, that text at the top, that's in viewport height units because I wanted it to take a certain percentage of the height of the slide. I didn't want it relative to the width of the slide because I wanted to keep it, make sure there was enough space here. If I made the narrow, then it'd stay that way. So the viewport size, maybe it's relative to the viewport size. In that case, use viewport units. If you're relative to the text, maybe it's just relative to the font height, then you're going to want to use M's or Rems. But if you're relative to the pitch, which is in this mention, if you're CJK, you probably still want to use M's. But if you're not, you might want to use the CH unit, which is defined as the width of the 0 character. So it's pretty closely related to the width of various letters that you might be working with. So how much text can you fit on a line? It depends on how fat the characters are. So the CH unit is better than M's. If it's a tall, skinny font versus a very fat font, you're going to get different amounts of text on the line. Or maybe, and in a lot of cases, it's relative to the content size. In that case, auto might be getting you exactly what you want, or the min content or max content keywords will get you access to those measures directly if you want those. And perhaps you want some combination of the above. You can use calc, you can use flex, you can use the min width and max width properties. Think about what happens when you make things narrower. Where's the limits? where are the limits on getting too wide, where the limits are getting too narrow, and tell those limits to the layout engine, and it will honor the limits for you, or at least as best as can. Absolute units, such as pixels and inches, are usually not the right answer for why am I making this size. It's usually not I want it to be exactly that size. It's usually I want it to be this relative to this other thing. I want it to be, something. Another thing is the same thing applies for media queries. You can set media queries in M's or CH's. You don't have to put them in pixels. One of the cool things about this is that if I increase the font size, well, let's see. Like if I change the size of this page, you can see that it has some breakpoints, and the layout changes a bit as we drop down. But the important thing is here that the breakpoints are about how much text I can fit on a line. If I can't fit a reasonable amount of text side by side, I don't want to have two columns. If I increase the font size, like this, I have the same problem. The text doesn't fit side by side, and so the media query, I haven't changed the size of the page, but I can fit less text side by side, so I should also have that trigger the breakpoint. There's no reason not to. And so if you size things in M's, you get kind of like font size handling for free almost, if you're already doing breakpoints. And then the last one is kind of not related to layout, but please use shorthands. Protect yourself against invading rules. If we take a look at this example, what color is the box if it has both of these selectors? Clearly higher specificity wins, right? It's going to be green, but the background also has an image. The image cascades in with the color. The image is laid over the color. We have a red box. Red is bad for testing, so that's clearly, this was not what I intended. I intended the background color to be green. The solution to this problem is use the shorthand. We want to set a blank slate. That's the thing to use as a shorthand. The CSS Working Group actually uses as a design principle when we're trying to figure out what should be a shorthand of what are the things that need to be set together? What are the things that need to be reset together? And what are the things that should not be reset together? For example, text decoration has been recently expanded to also set the color and a couple other things. But we also have a text decoration position, text line position, so that if you need to move the underline to the overline side, which is what happens in vertical text in Japanese, that does not get reset with the text decoration property, because that's actually going to be independently set by a different set of rules based on your language, and is not going to be relevant to I want this underlined versus I don't want this underlined. So we're definitely trying to think about this stuff and make it easier for you to get the right results and not run into problems like this. Borders, for example, and also as we add new properties and new abilities to CSS, we will make sure that the things that do the resetting will reset all of the things that should probably get reset together. So everything, anytime we add any background property, whether or not you can, background shorthand will reset them all. Border image will get reset. If you set border : none, that will also reset the border image, so that when you say border : none, you get a blank slate. There is no border. If in level 5 we add a border character left property, that will also get reset by the border shorthand. So this is a way to protect yourself from unintended cascading. And if shorthands are awkward to work with, you can break them down. You can set border none and then set other things. Or if background is there's too many things, you don't want to say no repeat and repeat yourself 5 times. You can set a bunch of other stuff in the shorthand and set no repeat once by just using the longhand. So use the longhand for targeted, I want to tweak this specific thing and not touch other things. That's it. That's why I'm done.
Excellent. We have some questions then.
Okay. Shall I close this?
Whatever. Show kittens or something. So that's egg on your face of everybody who started tweeting, I could do it better than the W3C. It's really easy stuff. That was actually one of the questions. How does someone get into spec writing? The learning curve seems to be very, very steep. As in, what went wrong with your life?
I filed a bug report
Yeah.
against Mozilla.
That's how it starts with
That's how
everybody.
it started. Well, I mean, we could go further back. I found a book on HTML and I read it because I was bored. And then I filed a bug report against Mozilla, and somebody fixed it, so I filed more bug reports. And then I started writing test cases, and then I started, explaining, okay, here's what's wrong. Here's where the spec says what you're supposed to do. Please fix it. And then I started finding places where the spec didn't say what you're supposed to do, or it said two different things depending on which section you read, or just clearly didn't make any sense at all. And I started reporting those bugs to W3C. And at some point they got tired of getting my bug reports and said, why don't you join the working group and help us write the spec?
It's probably like an email coming, I have no idea what she's doing. Maybe she should write that thing. I'm not quite sure what's going.
Yeah, there was a little bit of that. I think I actually joined the working group to work on international typesetting for the CSS3 text spec. Because I started out being like, I don't understand anything in the spec. It's like all international stuff. I don't know anything about international stuff. But I am a good copy editor. I'll find grammar errors or something. And I read the spec and I started finding sections that didn't make sense. And so I started reporting those and I started digging into it and just, if you get curious about something, you get good at it, basically.
It does. It can come across as a bit elitist, so at times. It feels a bit like it's harder to get into that than to do something on the What working group, for example. Is there something in the I mean, you're just an advisor to the W3C, but is there a movement to make this more applicable? Is there something like here's a bit of the spec that needs some real use, testing, these kind of things, or?
Well, we have a mailing list. The technical discussion of the CSS Working Group is all on that mailing list. We have telecons and face-to-face meetings, and the minutes to those are all posted to that. And the minutes for the CSS meetings, by the way, are pretty complete. They read almost like a transcript.
Yeah. They're sometimes really short. They're sometimes really short, like 4 or 5 sentences as well. That makes sense. And the follow-ups are coming every week as well.
Yeah. And when we want feedback, we'll post to the mailing list and say, we have a blog. We post, hey, we publish a new draft. Please give us feedback. But a lot of times we don't get feedback. Like the box alignment spec, vertical centering people. It's going to happen sometime soon. But nobody has commented on it. So Tab and I are we're pretty sure there's errors here, but we're not sure what they are.
Because sometimes there are misunderstandings. I mean, the amount of people that do a div height auto and then wonder why it's not the height of the viewport or not 100% height is people write blog posts to explain that kind of stuff. What do you think is the problem there? Where do people miss the logic of the spec?
Well, in that particular case, percentages going against auto, the reason for that was that you didn't want to have a cyclic dependency. So if you have a height that depends on the content and the content height depends on the containing block height, then you have a bit of a problem. And so the spec was just we're going to break this cycle by saying it doesn't apply. And so that's in the spec. One of the problems with the specs is that, you have to read a lot of dry prose, and CSS 2.1 is not the most well-organized of specs. We're getting better, right? So if you look at some of the newer specs, like Flexbox, for example, Tab and I went through a lot of effort to try and put some examples, organize the spec in a way that if you read it from the top to the bottom, it makes sense. And in each section, we organize this stuff. So if you're an author, you probably want this stuff first, so we put that first. And you just kind of read until you lose interest, and then you probably don't need to read the rest of the section.
Describes a few of my jobs, yeah.
So the way to get involved is basically hang out on the mailing lists, post about stuff you're interested in, play with it, report bugs. Honestly, the way I got involved, the way Tab got involved, the way Hixie and David Barron and a lot of these spec writers got involved was reporting errors to either browser vendors or the W3C or both. And as you get better at reading and understanding the specs and understanding what's wrong, you start, being able to make proposals that make sense, and that is what people are you're doing a good job of helping us fix the specs. Why don't we put you in charge of one part of it?
Writing by osmosis, so to say. Writing by osmosis, so to say. Like,
Yeah.
you're here already, you might as well start working with us. Just hanging out of offices and companies, it works the same way. Well, one of the biggest things that I mean, of course, everybody in JavaScript world always says like CSS is completely broken, it's a terrible language, and now other people say like we have to render everything in Canvas or WebGL to get 60 frames per second. But the vertical centering is still the main thing that everybody points out. Is there anything in the near future to make that more obvious and more easy for us to do?
Yeah, the box. So the properties that you learned about for Flexbox, the plan is to make them to apply to all elements. So if you want to center an absolutely positioned element, you can just say align self center. Or if you want to center the content inside a block box, you can say align content center, and that will just work. The main reason why this hasn't happened is that Tab and I have a really long list of specs that we're working on, and so we keep cycling back through things, and it takes a little while to like.
I'm kind of worried that I heard Tab and you all the time. Like, isn't there a way to ramp that up and get more people involved?
Yes, review our specs.
Yeah.
Send us comments. And
because if you get hit by a bus, then it's just Tab, or the other way around. That's just not good, you know.
Yeah, I don't like. The way to get involved is basically to get involved. I worked as a volunteer for a bunch of years, and before I started getting paid.
So if that's what your professional life is going to be, just work for a few years as a volunteer that doesn't get paid, and then
or you can get hired by Microsoft and be sent as a representative.
Or Mozilla, there's lots of spaces there now.
Right. What I have noticed is that if you are sent to people who are sent to a CSS working group from a company will either do well or they'll kind of like fail out by like not really doing anything and stop showing up to meetings. And the people who are successful are people who are really interested in it, like they really care. And they care enough to push back against management and say, no, I'm going to spend time on this thing, as opposed to like doing all of the things that hit your bottom line for your whatever it is you're doing. And they're people who, can follow the technical level of the discussion that's happening, which is pretty high. Like if you sit and listen to a CSS working group meeting, we're throwing around terminology like all over the place. And like, you got to work your way up to being able to follow that.
Yeah, I mean, that's any company. I mean, I learned so many three-letter acronyms in my first 2 meetings in Microsoft that I never heard before. So it's like listening in and not getting discouraged is a good thing.
Yeah, you have to be very stubborn and you have to speak up.
Yeah.
Right. So if you're going to go to a standards meeting and not say anything, you might as well not be there. It doesn't help anybody for you. I mean, it's good to listen until you understand what's going on and not, spout off nonsense. But people who don't get the guts to like say, I have an opinion on this, I'm going to say it. Like, you're not really contributing anything if you hold back.
Yeah. And I mean, I was saying glibly that there's spaces in Mozilla, but there are, and there's people in lots of companies. It's quite amazing how many of the CSS specs came from Mozilla people and ex-Mozilla people, rather than from big corporations. Or it's like most of the spec was written by, well, Tab is from Google now, but for example, Hixie was at Mozilla when it started as well. So it's an easy company to get into, or an easy foundation to get into as well, and easier than just becoming it your job. One clip one here. If a line break creates a new fragment, why does it seem so hard, take so long to create an nth line selector?
So the problem with the first line selector, and also the nth line selectors, is that they don't follow the box tree. So you will have, like, normally if you have an element and it contains another element and that element breaks, it still contains all the pieces. Whereas with a line box, you have an element and it might contain part of the element and then not the other part. So let's say like the first line element, it has, color purple on it. That needs to inherit into this fragment and not into the fragment that's on the second line. And this is kind of painful for Gecko, at least I know it is, and I'm pretty sure for other layout engine, it's not natural to the way that the layout engine is architected. And it's not entirely 100% like well understood in the spec either. Like I'm actually, one of the things I need to do is help clean up that part of the spec that I've inherited. And so the nth line selector is just like, oh, we're going to have more of this first line stuff, which is really like junky. It's hard to do. It's full of bugs. It like possibly like, you know, could create crasher problems if you like tangle up your pointers for your frame tree, because this is all in C++, right, in Gecko. So we get these kinds of problems with the seg faults.
Well, I get a lot of these is also like, I want to style every single character in a letter differently, and you're like, that sounds like a great thing, but why? You know, it's like, it seems like we're, in computing, we always think because it can be done, the engine should do it for us, but the use case is something that maybe, I mean, there's a lot of specs out there that nobody ever used.
Yeah. So,
and others are getting reinvented as a JavaScript library and don't get into the specs because people ask for the wrong things.
Well, we want to solve like the common use cases. Styling every letter a different color is not a very common use case, so it's not really worth putting a lot of effort into it. And if you really want to do it, you can do it in JavaScript. Like, you know, if you're a fringe case, then you know, do it in JavaScript. There's so much that needs to be implemented and spec'd and tested and like deployed that is important to all, like everyone, like vertical centering, right? You know, grid layout, like fixing all of the bugs in the various Flexbox implementations. These are important foundational things that you know, help 80% or more of the websites out there. And so that's where we would prefer to apply our efforts rather than like, you know, nth line, which, yeah, there's definitely use cases for that, but like the difficulty of that versus the benefit of that versus all the other things we have to work on, it's not been a high priority. Maybe in 15 years, like people will be like, oh, nth line, we're totally ready to do that now. Once you've got a whole bunch of the regions and the page, like we have similar problems with the inheritance and selection and stuff with selecting content on left versus right pages to style them differently, or like regions have related problems, and those are a little bit more compelling use cases to solve these kinds of tree problems. And as we work our way through those problems, this might end up getting solved along the way. But it's since it's a complicated problem and it's going to require a lot of effort from a lot of people, spec writers, testers, implementers, etc. And it's not, nth line itself is not super huge priority. We're working on other things right now.
I always get the impression that a lot of things when people say like, oh, the spec is far too complex, is because people never thought of internationalization and international problems like right to left and different ligatures and different fonts. It's a massive problem to actually write a spec that follows everything worldwide, and it's the World Wide Web. So I learned a lot when I had to do like multi-language websites out of a sudden, and like, yeah, as we saw earlier, like left to right is not enough. If you do like the HTML drop-down menus back then, it had to flip out to the other side that right to left didn't do for me. So one question here is like, any update on animating width and height auto values?
I don't have an update on that. I think it's like,
use jQuery.
the general impression I got the last time the CSS Working Group discussed it was that, yes, that seems like it would be super useful and we should do it, and not right now because we still have to finish the existing set of features that are in animations. But I think they want to go there, but it's probably going to take a little while.
One of the interesting things we found when we just wrote Microsoft Edge is that we didn't have XPath and we didn't want to implement it. So we rendered every XPath request through the CSS rendering engine, because most of the requests of getting part of the document was possible with CSS render with the CSS syntax selector engine as well. So it's interesting that CSS selectors became so powerful. Would you think with generated content there would be, in the future, there will be much more access to that? We just generate right now, as we saw earlier, that hack of animating a generated content. The content was only way of like doing an overflow and doing the text in that. Is there something going on more that CSS becomes more of a generation rather than just a designing thing?
I think we don't want to go there because the content should stay in where the content is. Like, for accessibility reasons and for just reuse of the document, you want the content to be in the HTML and not in the CSS. So we don't really want to expand generated content to the point of being able to do all of the stuff that XSLT does. There's definitely a use case for transforming documents from like simpler and to more verbose and like there's a continuum of like data and then like the various presentation of it, right? HTML is a wrapper around some database, and so it's part way along towards presentation as well. But I think that would make more sense to solve with an actual like transformation language that's designed to do those kinds of things. There's Daniel Glasman keeps talking about we should have the equivalent functionality of XSLT in a CSS-based syntax, but it wouldn't be CSS. So CSS is about styling. It doesn't affect the DOM. It sits on top of all of that, and it's just like a rendering. It's the presentation.
Simplifying XSLT would be nice, though, because it's not fun to write. No. If you were to start from scratch nowadays, what would you do mainly differently in a browser engine? What would be the main CSS thing that you would make differently that cost you a lot of your nerves over time?
I don't know about costing me a lot of nerves over time, but I think box sizing should have been border box by default. What do you think? Logical directions. Yes. Yeah. So that's an international
helping
thing.
You had your time. You squandered it away on random things or photos of me. So no.
So John Daggett's talking about logical directions, and I think you guys touched on this with the SAS talk actually. And so we have left and margin right and top and bottom. But like when you are designing for multilingual stuff, you want those to automatically swap. You're not talking about the margin left. You're actually talking about the margin start. The start edge, the inline start edge margin and the inline end edge margin, or the like block start or block end margin. And so CSS kind of screwed up a bit in the sense that most of the time the styling you want is logical, and sometimes it's physical. And that's something that hopefully we'll solve in the future, but we're not anywhere near that.
Excellent. So I think that's all the time we have. So I had a few more questions, but I know that the next speaker is going to cover them. So you're off the hook. Thank you very much.
Okay.